Imagine you are flying at 250 kilometers per hour, you can't see the runway, and the ground is somewhere below that blanket of fog. Yet, the airplane touches down as if guided by invisible rails. How? That's the magic of the Instrument Landing System, or ILS. I welcome you all to Aerominds Training Center, and today, we'll uncover how the ILS allows the pilots to land safely in near-zero visibility. From the antennas on the ground to the needles in the cockpit, you'll see exactly how it works, and by the end, you'll be able to read an ILS like a pilot. The Instrument Landing System, or ILS, has been guiding pilots to runways for over 40 years. And guess what? Even with all the modern GPS tech we have today, ILS remains the most accurate landing aid in use. Why? Because it offers something no basic system does: precision guidance in both planes. Horizontal, side to side, so the aircraft stays aligned with the runway centerline. Vertical, so the aircraft stays on the correct glide path down to the runway. It's so precise, many modern aircraft can even perform fully automatic landings using ILS. This is what we call a precision approach, because it gives continuous and accurate guidance all the way down. So picture this: you're flying in low visibility, descending on instruments. The ILS needles guide you right down the imaginary slope, known as the glide path, straight to a safe touchdown. But here's the catch: you don't land blindly. At a certain height, called decision height, you must have sufficient visual references of the runway. If you don't, you go around and fly the missed approach procedure. ILS is all about safe decision making, precise flying, and structured procedures, which is why it's still the top choice for critical approaches. Let's break down the ILS into its three main components, starting with the localizer. The localizer is the part of the ILS that gives you lateral guidance. In simple words, it helps you stay perfectly lined up with the extended runway centerline. It's located about 300 meters from the far end of the runway, that's the upwind end. It transmits in the VHF band, between 108 to 112 MHz, with 40 channels, and these frequencies are shared with the WAR system. So only specific ones are used for ILS. The localizer sends out two overlapping beams, one modulated at 90 Hz on the left and one at 150 Hz on the right. Your cockpit instrument compares these signals. If the aircraft is perfectly centered, you get equal signal strength. If you move left or right, and the needle will deflect, telling you to correct. So essentially, the localizer acts like an invisible runway centerline that stretches out for miles, and your instruments keep you glued to it. Now that you're lined up with the runway centerline thanks to the localizer, how do you know when to start descending, and at what angle? That's where the glide path, or glide slope, GS, comes in. The GP transmitter is located about 300 meters in from the threshold and around 200 meters to the side of the runway, usually next to the touchdown zone. It operates in the UHF band, between 329.15 to 335 MHz, also with 40 channels. Just like the localizer, the glide path uses overlapping beams, one modulated at 90 Hz above the slope and one at 150 Hz below. The cockpit instrument tells you whether you are above, below, or on the ideal descent path, typically around a 3-degree glide slope. This gives you smooth, stable descent guidance, no sudden drops or steep dives, just a perfect slope leading down to the runway. Now that we've got the lateral and vertical guidance sorted, let's talk about range, how far you are from the runway. Enter the marker beacons, a set of transmitters placed along the approach path that help pilots cross-check altitude and distance. They all transmit at 75 MHz, but their signals are sharply focused in a vertical fan shape, which means you'll only receive them when you're directly overhead. There are three types. Outer marker about 4 to 7 nautical miles from the threshold. A blue light flashes and a slow, dash dash, tone is heard. Middle marker about 0.5 to 0.8 nautical miles from the threshold. Amber light plus faster, dot dash, tone. Inner marker found only in Cat 2 or 3 approaches, very close to the runway. White light plus rapid dots. These beacons give pilots an extra layer of confidence. Am I where I'm supposed to be, at this altitude, at this distance? However, not all ILS installations use all three. In many places, only the outer and middle markers are used, or sometimes, none at all. In modern ILS setups, DME, or distance measuring equipment, is often used alongside, or instead of, marker beacons. The cool part? The DME is frequency paired with the ILS, so when you tune in your localizer, the DME automatically syncs up. It gives you a continuous distance readout, zeroed at the runway threshold, unlike markers which only beep at fixed points. But DME has its limits. Within the localizer coverage area, it works accurately, typically up to 25,000 feet and 20 to 25 nautical miles. If you are outside that zone or using it outside published SID or STAR procedures, errors can creep in. So pilots must always cross-check, but when used properly, DME makes ILS approaches smoother, smarter, and safer. Alright, so now that you understand how ILS works, how do pilots actually read it in the cockpit? ILS information is displayed on two key instruments: the course deviation indicator, CDI, and the horizontal situation indicator, HSI. Both instruments show the same basic idea, whether you are on course and on glide, or if you need to correct your position. The CDI is simpler, you just follow the needles. The HSI, though, has a course selector, and you need to set it to the QDM of the runway, that's the magnetic heading to the runway. Once set, the HSI gives more intuitive guidance, the deviation appears in the correct direction, so it's easier to follow. Let's start with the localizer needle, your left-right guidance. If the needle is centered, you're perfectly aligned with the runway center line. If it moves to the right, you're left of the center line. Fly right to correct. If it moves to the left, you're right of course. Fly left to correct. 1 dot equals about 0.5 degrees of deviation. Full-scale deflection equals more than 2.5 degrees off course. Small inputs, steady corrections, that's the key. Now let's talk vertical, the glide path needle. If it's centered, you're right on the ideal descent angle, usually 3 degrees. If the needle moves up, you're below the glide slope. That means, fly up. If the needle drops down, you're too high. That means, descend more steeply to rejoin the path. Each dot here equals about 0.14 degrees of deviation. So 2 dots equals around 0.28 degrees, and full scale equals you're off by more than 0.7 degrees. That's a big deal on final approach. Important note, if you see more than half-scale deflection, you should immediately go around. Because below that glide path, terrain clearance is not guaranteed. Not all ILS systems are created equal. Based on how close they guide you to the runway before you need visual contact, ILS is classified into 3 categories. Let's break it down. This is the most common type worldwide. A Cat 1 ILS guides you down until you are around 200 feet, 60 meters, above runway threshold. At that point, called decision height, you must have the runway in sight to continue landing. It's great for light fog, mist, or night operations. Category 2 is more advanced. It brings you all the way down to about 50 feet, 15 meters, above the threshold. This allows landings in much poorer visibility, but still needs special ground equipment and aircraft capability. And then there's the elite club, Cat 3. This ILS system, sometimes combined with Autopilot and Autoland, can guide an aircraft all the way to the runway surface. This is the system used in zero visibility, heavy fog, or snowstorms. Aircraft can land without the pilot ever seeing the runway, until they're rolling on it. However, Cat 3 needs special certification, from the ground equipment to the aircraft avionics to the pilot himself. From theory to cockpit, now you know how pilots land safely in near zero visibility. If you found this helpful, subscribe to Aerominds right here on YouTube. And for daily aviation info, DGCA updates, news, and study tips,